This is the second note of the 6th unit on interest. This note specifically, we will be talking about simple compound interest. So comparing the simple interest to compound interest. Okay, so the simple way to calculate compound interest. So compound interest is interest paid on the principal and its accumulated interest. The interest is calculated at regular intervals or regular interval periods and then added to the principal for the next compounding period. A compounding period is the amount of time for which interest is calculated and being accumulated. Okay, so our simple interest was just interest paid on the principal, right? It didn't have this and its accumulated interest. Okay, so this will differ slightly, and I'm hoping that you'll be able to see that with the next couple examples that we do. So this first example says calculate the amount of a $3,000 investment after each year for 5 years at 8% simple interest. So this is simple interest. So this is what we learned in our last note. So again, we're taking information from the question. So we invested $3,000 for 5 years at 8% simple interest. So as you can see how our chart is set up here, we're just going to do year by year. Okay, so we're not actually going to use that same equation that we did in the first unit because we want to see how much interest is going to be accumulated each year. So the principal each year is going to be $1,000. Okay, that principal is not going to change for simple interest. It's always just going to be $3,000. In order to calculate the interest, we use our formula from that first lesson, which is I equals PRT. Okay, the time for each of these years is just going to be 1, right? Because we're calculating for year 1 and then we're calculating for the second year. We're not calculating for 2 years, just the second year of this situation. Okay, so I equals, so in interest, I have to take my principal, which I'm just gonna, it's already there. So principal times my rate, which is 8%. So as a decimal, that's gonna be 0.08 times 1. And that will give me $240. To calculate the total amount, remember you're just adding the principal plus the interest. So that's A equals principal plus interest. Principal is 3,000 plus 240 means that we have a total of $3,240 after 1 year. Okay, so after each of these years, you're going to make the exact same amount of interest, okay, because it's simple interest. So again, you would just do this exact same formula. Because it's only been a year, so you're making $240. You're going to make $240 after that year, $240 after that one, and $240 after the last one as well. Okay, so the interest you're making doesn't change. To calculate the total amount now, what we need to do is we need to take the amount we made after year 1 and add 240 to it. So plus 240 means that our total amount after 2 years is $3,480. To figure out the next year, we're adding $240. Okay, and it's just the same pattern over and over and over again. So after the 5 years, if I continue to add $240 in interest each year, I'm going to end up with a total of $4,200 after 5 years. Okay, so it wants us to also graph our results here. So I'll do this one in blue. So what we first invested, so no time has gone by, we invest $3,000. After a year, we're at 3,240, so approximately there. After 2 years, we're at 3,480, so 3,4 somewhere in there. After 3 years, we're at just about 4,000. After 4 years, we're at 4,200. And I'm wondering, did I calculate one of these wrong? Because that should be a consistent straight line. So 1, 2, 3 years. Yes, I just plotted the point wrong. 3 years, 3,720. 3,720. That makes more sense. So, you know I'm not going to be able to do this, but what you're going to do on your page is you're going to try your best to connect those dots to show how much money you are making with this simple investment. Okay, so now it says use simple interest to calculate compound interest. To calculate the amount of a $3,000 investment after 5 years at 8% compounded annually, so same amounts as before, right? Use the simple interest formula for each year on the principal and previously accumulated interest. And again, graph your results. So this differs slightly, okay? The first line is going to be the same, right? Our principal that we're putting in is $3,000. In order to figure out that interest, I'm again multiplying by 8% as a decimal. And it's been 1 year. So just like before, my first year, I make $240 in interest, which means my total amount is $3,240. Okay, so that's after the first year. This is where it differs. Okay, so now that it's been a year, your total amount becomes your principal. So now you're not making money on that $3,000, rather you're making money on $3,240. Okay, so you just take your amount from your total amount and move it over and it becomes your principal. Okay, because you're making extra money on that interest. So we're going to multiply again. It's the same percentage and it's only been a year. But this time we're making $200 and almost $60, $259.20. So again, we're taking our last total amount and adding the interest, our new total. And you know what I'm going to do just to make things a little bit clearer is I'm going to just round up to a whole number. Okay, so our total amount here is now 3,500. Okay, so because we have interest, that is going to become our new principal. So we take our new principal, we're going to do the exact same thing. Multiply it by 0.08, multiply that by 1. Okay, so now our interest after this year, and again I'm going to round out up here, $280. So now my total is $3,780. Okay, that total amount becomes my principal. Because the benefit of this compound interest is that we make money on the money we've already made. Multiplying by 0.08, multiplying by 1. This time I'm making $302. Okay, that means my total amount is $480. Okay, that becomes my new principal. $4,080 times 0.08 times 1. This time I'm making $327. Okay, and these numbers might be slightly off again if you're following along, because when I initially did it, I didn't round to a whole number. Okay, so $4,080 plus 327 is $4,407, I think. Let me double check. Yes, beautiful. Okay, so now let's graph this. So again, our initial amount before we've invested is going to be the same as before. After a year, we're making the same amount of money as before. After 2 years, though, now I'm at $3,500. So my dot's a little bit higher than the last one. After 3 years, I'm at $3,780. So again, I'm a little bit higher than before. Somewhere in there. After 4 years, I'm at 4,000. Oh, this is what I did. I missed one completely on the last one. 4,080, so somewhere in there. I'll fix the last one in a second. And after 5 years, I'm at 4,407. So somewhere in here. And let me just go back. Guys, I missed. So year 4 was 3,960. So that is just under 4,000. And year 5 is 42. So it should look something like that. So again, you guys probably have this printed off. So if you connect those lines, you will see that your orange graph, or my orange graph, is making more money than the blue graph, right? At first, after the first year, they're making the same. But as soon as that second year comes around, you can see that that compounding interest ends up making you more money, right? And by year 5, there's a huge gap, right? You're making $200 more. Okay. So, question says, how much more is the compounding investment compared to the simple interest investment? So at the end of our 5 years, our compound made 4,407, and our simple interest made 4,200. So you take out your calculators. 4407 minus 4200 means that you made $207 extra with the compounding interest. So more with compounding interest. Okay, and hopefully these two charts, obviously we aren't going to have to use charts to actually figure out these amounts, but the reason that I've showed you these is that you can compare directly. If everything is the same, you'll still be able to see the differences between simple interest and compounding interest. So moving on, just as a quick summary. So what type of interest has linear growth, and which type of interest has exponential growth? So if we look back at this graph, you'll notice that with my blue line, if I were to find like the slope, I'm technically just going up 2 squares-ish each time, right? It's not perfect because I graphed it just freehand, right? So that graph is actually linear, because remember from last year, like we don't really talk about it much in this course, but a linear line has a slope, right? It's consistent, it's a straight line. Compounding interest, on the other hand, we can see that initially I start off going up 2, but then I quickly start going up 3 and even 4 squares at the end, right? So that's an example of exponential growth. Okay. Sorry, I just realized it says because simple interest has linear growth because it increases by the same amount each year. Okay, compound interest has exponential growth because with more years, there is more rapid growth. Okay, so to summarize, at the end of each time interval, the simple interest formula is used to calculate the interest, which is then added to the principal or previous amount. Okay, the key thing here is that the interest is added to the principal. Okay, so that's the one thing you want to really take out of this lesson. Okay, example 1. $500 is invested at 2.4% interest compounded annually for 3 years. Use the simple interest formula to calculate the total amount after 3 years. So I'm going to go back through and highlight here. So $500 is invested, 2.4%, compounded annually for 3 years. Okay, so just like before, it wants us to just simply use that simple interest formula to calculate how much we're going to have at the end. We will get to this more in our next note, but just so you know, compounded annually means yearly. Yearly is another word for annually. And this is compounded, right? So that's when we have to add the interest and then use that new amount as our principal. So our initial amount that we invested, or our initial principal, is $500. Okay, to find the interest, again, we're multiplying that. It's only been a year, so we're multiplying by 0.024 times 1, which means we're making $12. Okay, to find our total amount, we take our 500 plus our 12. Our new total amount is $512. Okay, for year 2, our principal is now that total amount from year 1. So now our principal is 512. So we need to, again, multiply that by our percent and our year. We'll get $12.30 now. So our new total is $524.30. Okay, again, it's a new year, so I take my new total amount, which is $524.30, multiply it by that same decimal, multiply by 1, which you don't actually really have to do, right? Anything times 1 is itself. Now I'm making $12.60 this year. So now I have $536.90. Okay, so we can see we're not making the same amount each time, right? We make $12 the first year, then we make an extra 30 cents, and then we make another extra 30 cents as well. Okay, so it says if the interest was not compounded, how would the final amount be different? So remember, if something isn't compounded, that means it's making the same amount of interest each time. So the final amount is going to end up being less, right? because we're talking about a small amount here with a very small interest rate, it's kind of hard to see the difference. And it's kind of hard to see how that really matters because it's not a lot of money, but every cent kind of counts, right? So the difference would be that in year 2, we would also just make $12. And in year 3, we would also just make $12. So the total amount would be less because the investment would only make $12 each year. Okay, and again, we can't really see how that would be a drastic change right now, but if we continued with this, we would start to see kind of a larger difference in our numbers. I just want to double check to make sure my numbers were correct here. Yes, okay, perfect. All right, moving on to example 2. Harleen wants to borrow $7,000 for 5 years. Compare the growth of this loan at 7% per year simple interest to the same loan at 7% per year compounded annually. Okay, so again, I'm just going to highlight that information. So we want to borrow $7,000 for 5 years. Okay, the percent is going to be 7% per year. So simple interest, remember our formula to figure out your interest is I equals PRT. Okay, so the initial amount is the amount we're borrowing, which is $7,000. Okay, R is our rate as a decimal, so 0.07, and the time period here is 5 years. If we multiply all of those together, we get $2,450 in interest. Okay, to figure out your total amount, that's principal plus interest. Your principal was $7,000. Your interest was $2,450. That means in total, what you're going to owe after you borrow this money is $9,450. Okay, total. So you borrow $7,000, but there's interest on that money. You're going to end up paying over $9,000 back. That's if we have simple interest. Okay, let's see if it's any different if we use compounded interest. So again, we're doing it per year. So after the first year, our principal is $7,000, right? That's how much we borrowed. To figure out the interest, we're going to multiply that by our percent and the year, which is just 1 year, which means we make $490 in interest. Okay, so notice how the situation has changed, right? Before, we wanted to make money on our investment. In this case, we're borrowing money. So this money we're going to have to pay back. To get that total amount, we just have to add our principal and our interest together. That means just after 1 year, we're going to owe $7,490. Remember, the difference with compounding interest is that that total amount now becomes your principal. So now you're accumulating interest on that new value. So again, you're always going to multiply it by 0.07 and 1 because we're just trying to figure out in this year. In that next year, you now accumulated over $500 in interest. So your new total amount that you're owing, if you add those together, is over $8,000. Okay, that $8,000 now becomes your starting amount in year 3. Multiply that by your percent and your year, which is just 1 year. After the 3rd year, you are going to owe an extra $561. That brings our new total to $8,575.30. That now becomes your new starting value for year 5. Okay, this is assuming you're not paying it off at all throughout these 5 years. So you borrow some money, say from OSAP, because you might actually experience that. You borrow the money, that money immediately is going to start accumulating interest. I guess not necessarily for OSAP, but in any other terms of loan. So if you're not paying anything back on it right away, then this is the situation that you're going to be in. It's going to just keep accumulating dollars. So after your 4th year, you have $600 in interest just in that 1 year, compared to the original $490 that we started with. Okay, which means we now have a total of $9,175.57. Remember, our new total becomes our principal in our next year. Multiply by your percent and your time, which is just in a year. And this year, we made $642.29 in interest, which means after this 5th year, we are going to owe $9,817.86 to the person that we took this loan from. So, comparing that with simple interest, right? So for our compound interest at the end of our 5 years, we owe, I'm just going to round here, we owe $9,818, okay? But if we were in simple interest, we would only have to pay back $9,450. So that means the difference there is $368. So compound interest will make you more money, right? But it also will make you more debt. So if you have a situation where you're borrowing money, we want to use simple interest. But if we have a situation where we are up here, where we are trying to make money, we want to use compound interest. Okay, so $368 more with compound interest. All right, so we'll discuss compound interest in a bit more depth in the next lesson, but this is the end of the second lesson on simple versus compound interest.